Mr. Grandaway, you're an awesome teacher. I just want you to know that.
Thank you, Marcus. Extra points for you.
Not.
Now you earn even more points if you subscribe to my channel.
No, because that's not really
Give me an A.
Okay.
Yes.
Okay, so
Can I do it?
as an opener, we have a little challenge to do here. So with your partner on page 89, read the directions. There are 4 steps. See if you can complete the construction using the directions. And I'm going to give you
Can I do it, please?
not too long to do it. So maybe about 5 minutes. Follow the directions. See if you can do it. If you need help, I'll come help you. Okay, so after you've made those constructions, this is what it should look like. Remember that even though Q intersects the circle in 2 places, only one of those is relevant and actually makes a parallel. So, any questions about that? The hard part is that there are 2 components to constructing each circle, right? Figuring out the radius of it, and then actually moving your compass towards the center that you want or need. Okay. See, the little note tells you. They intersect in 2 locations, pick it so that they're opposite half planes of line, which really means pick the point that's going to make a parallel.
But I didn't know what C1 and C2 were.
C1, circle 1, circle 2.
Oh.
Circle 1 from step 1, circle 2 from step 2. Cool. All right. We're rejoicing. Wait, no, I am. No one else really is. Oh. Now you know who's here and who's in here today. Okay. So. Oh, wrong one. Let's have a little discussion about translation. So we've talked about these different shapes that we're using for different transformations. Dylan, what's going on? Okay. So one of those shapes was this upside down V. Remember what that stood for?
Like a reflection?
Yeah, we said that's kind of like a reflection because if you draw a circle or a line through the middle of V, then it like reflects onto itself. So that kind of helps you remember that it's a reflection. What did we use for a rotation?
R.
R. And then R has 2 little subnotes. One is the point around which you're rotating, whatever point that is. And then the other one is the angle of rotation, right? So just help you remember all this notation so if you see it on a test, you know what it is.
So it rotates around and 30 degrees.
Yep. And which way does the 30 degrees go? Clockwise or counterclockwise?
Counterclockwise.
Counterclockwise into the first quadrant, remember?
Oh yeah, to see it on here.
Yep. Okay, doing all this stuff, remembering everything. So there's a capital T, and the capital T we use for the word translation. So if you see a capital T, it means we're translating. Now, if you remember from chapter 1, a translation, up and down, left and right, it's like shifting the whole figure. Does it change the lengths of the segments? No. It just changes the location. Mark it. Yeah. Where's your pass?
I have. Oh, great.
Okay. Sounds good. So, when you make a translation, you are applying something called a vector. Raise your hand if you've heard vector before. Okay. A few people. So let's envision that let's envision that we have a shape. And the shape will be a triangle. There it is. And we're going to move this triangle. We're going to translate it. I think what I can do is this. Oh, bummer. Just want that message. You can do it, Mr. Vandeway. Copy. Paste. Oh. No, but I want them to be the same size. Right? So I have just translated it. Do you remember we used like different, one was solid, one was dashed. Which one was the image and which one was the free image?
The solid was the image afterward. The finish.
Solid was the free image and the image was dashed. So we're going to follow the same kind of thing down here. I have just moved one triangle and mapped it onto the image. And this transformation is called a translation. And each translation has something called a vector. So the vector tells me which direction I'm moving it into, and then how far I'm moving it in that direction. So we talked about the solid shape being the image, or the pre-image. So here is our pre-image. Our image is on the left. The vector, the endpoint, the vectors are always rays. So they have one endpoint and then the other end goes on forever. And the endpoint of the vector is at the location of the pre-image. How many different vertices do I have in the pre-image? 3. That's a triangle. I can pick any vertex that I want. So say that I pick the top vertex in the pre-image. Where does this vertex end up in the image?
Right next to it. Yeah.
Right there? So this is the vector that tells me not only how far, like how long each movement is, but also in which direction it's headed. And if I want to, I could like take this vector here, make it solid so that it makes kind of sense. And I can copy it, paste it, and do you notice that if I apply the vector to the other vertex, is there anything I need to change about it? No, I didn't have to change its length or its direction. You think that'll be true for the bottom right as well?
Yeah.
Well, let us find out.
That's so weird. What if they're like...
So that's why it's a translation, because I'm applying the same vector to each vertex. Oh, cool. So, remember how we just constructed parallel lines the quick way? We're going to have to do that when we translate a figure. Because all of these lines, all of these vectors are what? Parallel. So that's what we're going to talk about now. So before we do that, turn to example 1. Which is on page 90, right? Bottom left?
Yes, it is.
And you get to draw the vector for each one of these figures that has a pre-image and an image. Remember to draw the vector from the pre-image to the image, and the pre-image is
Do
the
we have to
solid
do
one.
all of one?
All 3 of them. No, you could just do that for one. There, that'll be fine. But do that for each set of figures. We have to, listening audience. Okay, so make sure that you're drawing your vector from pre-image to image, and it doesn't really matter where you go as long as you start at one vertex, you go to the corresponding vertex on the other one. Now we're going to do this. If I give you the pre-image and I give you the vector, now we get to discern where the image goes. So example 2 in your booklet has that situation. We have a segment, P1, P2. I have a vector, vector AB. I'm going to apply this vector now. How many vertices do I have? 2. P1 and P2. We're going to apply this vector to those 2 vertices to find our image. How do I do it?
Do you measure AB and do a circle around
Yeah. So we're going to follow the steps that are similar to the opening thing that we did, our opening exercise. So really what you need to do first is to construct 2 parallel lines. What are they parallel to? Vector AB. And what are they going through? P1 and P2. So work with your partner on that, see if you can accomplish that task. Draw your circles, Dakota. There's plenty of stuff to do here. We're not just watching the screen. Okay. So to draw my second parallel line, I'm going to do the same thing. I'm going to draw another circle that has a radius of AB, but where am I going to place that circle?
On P2.
On P2.
Who came up with this stuff? What's the guy's name?
I'm not sure. Euclid, probably. He's the one who does
Pretty
all this
cool
stuff.
how it all works out.
I know it is.
I don't know why.
So same circle as before. AB. I'm going to take that circle and move it onto point 2.
Should read the manual.
It's hard to do digital.
Why don't you just talk or like
I don't have a giant compass.
oh, that'd be so cool. Then no, just get one of these and put a instead of a pencil. And then you can do it like that.
Sharky does.
I don't know how Sharpie does.
So you can go from there and continue on. So my second circle AB should be here. It's going to go through P2, and then I'm going to measure from P2 to A, right? That's going to be my radius. But I'm going to make a center B, draw my other parallel line. And then how am I going to plot P1 prime and P2 prime? Well, you can just use your compass, because what are we going to do here? We're just going to figure out how long AB is. So you can use your compass to make that measurement, and then you can plot that onto P1. So the center A is going to get plotted on P1, and that's going to tell you how long this is. Mine doesn't work at all, but yours will figure it out.
Mine is like circle below.
Okay, for example 3, we're going to do the same thing, but what's the difference here? How many vertices are we moving? 3. So you're going to need 3 parallel lines through P1, P2, and P3. So you need 3 parallel lines, and you're going to have to make them parallel to AB, figure out the length of AB, map that onto your new parallel lines, and connect the dots to make your image. Same thing as before, we're just adding another vertex. So let's see if I can figure out how to do this in Sketchpad world. So the first thing I'm going to do is take my compass to get the length of AB. Then I'm going to take that circle and make the center of it. P2, for example. Doesn't matter where you start. I'll take another circle, get the distance from A to P1, since Dakota insisted I do P1 first. Should probably move this over a little. Yep. But this, where's the center of that going to go? Yeah. I hate it when it does that. Okay, and then the sort of, there's my point. Draw your circle through there. Mm-hmm.
All the points that go around like P1, right? They're going to be measured in
So you can draw 3 circles right now without moving your compass. Is that what you're getting at?
Yep.
Yes. See, it moves it with it. I don't want to move that, I just want to move this. How can I move it so that it doesn't move it with it? I guess I can't. But I could do this.
P1 to B on radius B or to the center B.
Yes. So I've got 3 parallel lines. Now I can apply this distance from A to B to all 3 of these. So I use my compass, find the distance from A to B, take the circle, apply the length. And find the image. How do I do that? On here. I'm messing this up. I could probably do this. Edit, copy. And paste it. There we go. Yay. Paste it again. Yay. Paste it a third time.
What are we trying to make parallel right now?
I'm trying to make these 3 lines parallel to this vector. And now that I've done that, see I have these 3 new points now. 1, well it's actually not over there, but 2, 3. If I connect those 2 together, I get my new triangle.
Wait, why do you have 2? Why do you have 2 circles up?
Sorry, that one, this one's not right.
Yeah, that.
So when I connect them, they get like this. Oh, I don't want that one either. Maybe just connect the dots together to make the image. There you go.